Welcome back everyone and welcome to today's class. Today we're going to talk about traffic zones. Let's take a look at this network. We have a firewall with an inside interface going to PC1 with a private IP address range. Then we have a DMZ with real IP addresses. But on the outside we are multi-homed. That means we have two different connections to two different internet service providers. So on the left we have ISP number 1 with this IP network as a link net, and on this end we have another IP address. So what's the problem about this setup? Well, let's say we define this as outside 1 and this as outside 2. If the DMZ initializes a connection to something on the internet, so the packet goes to the firewall, gets added to the connection table, then it gets routed to ISP1 and along to the internet. When the return packet comes, it might go the same way, but it can take this direction as well. That means that the firewall will be receiving the return packet on another interface than it sent it to, and it will be dropped because it doesn't match the egress interface on the connection table. So that is what traffic zones aim to correct. With traffic zones we can group interfaces together. So we could have one outside 1 and one outside 2, but we can group them together in a traffic zone called outside. And then we apply all the rules like NOT and access lists and so on the traffic zone. Or we define our access lists and policies, etc., and assign it globally, so it affects all interfaces. Then if a packet goes this direction and returns this, it won't be a problem because it was sent outside the outside traffic zone and received on the outside traffic zone. So that's what we aim to configure here today. So far the most basic stuff is already done. The PCs are configured and the routers are configured, both the IP addresses and the routing. So what we have done left to do is basically configure the firewall. And in the firewall the inside interface is done, as well as the DMZ, but the outside is not configured. So let's start there. So if we check the interfaces, we see that gig 0 and gig 3, that's the inside and the DMZ respectively. And if we enable the ports, we can see that gig 1 goes to gig 1 on ISP 1 and gig 2 goes against gig 2 on ISP 2. And the routers will have the second IP address of the different ranges. The firewall will have the first. And this PC has .101 and this server has .3. Okay, let's do this. Let's start by let's start by defining this common traffic zone. So we do zone and we give it a name, outside, like this. Then we go into the first interface. I will set the description so it's easier to see what's what. And this will be to ISP1 outside. And we will group it together with the common security zone outside. So we'll do zone member outside. Okay, we need to set the name here first. Let's do that. And we'll name this ISP1. Then we set zone member outside. We set the security level to 0. And we set an IP address of 212.16.16.5. And this is a 30 network mask. Like this. And no shot. Then we go to the second and do basically the same. We give it a name, ISP2. Zone member outside. And we'll set the security level to 0. And an IP address of 212.16.16.1. 255.255.255.252. No shot. So this is our configuration this far. Let's see if we can ping the routers on the other end of the links. So this is ISP1. Yes. And this is ISP2. Okay, that works. So what else do we need? Well, we need some NOT for this interface. And let's see. I think we will so for this we can have that, and let's say we have an additional 193 network which is routed to the firewall, or announced from the firewall. So let's say we want to take IP address from 193.234.88, and we'll go from 8 to 12. Okay. So we'll create a network object network for 193 network, and we'll do range 193.234.88 dot what did I say? So 7 is the last, 8 is the first. We'll go from 9 to 12. And we will also set up routing back to the firewall for that network. We already have the first /29 routed towards the firewall, so we'll just change the mask of this route. Instead of 248, we'll set 240. So now the whole /28 network, that includes the DMC, but also these NOT IPs. And we'll do the same on this one. We'll remove this, and we'll change the net mask. Okay, like that. So we have defined the range, and now we want to create a not rule for that. So we have the range, we need to create an object for the 192 network. Subnet 192.168.10.0/24. Okay, so normally we would do not inside outside if we have just one outside interface, but we can't do this time. We could put ISP1, for example, but then we run into the same problem as before. And we can't put the zone either, because it needs to be a real interface in the NOT configuration. We can't just type the traffic zone. So instead, we may do any. So we'll go from inside to any outside interface. And we will resolve this range to, let's see, dynamic and our new 193 network. So if we check our NOT configuration, it looks like this. And if we do sh not detail, we can see that we go from inside to any interface, source dynamic from the 192 network, and we translate it to the 193 network, this range. So that's how you configure a dynamic NAT when you have a traffic group instead of when you have a traffic group instead of the regular interface. Okay, so I also want to make this server accessible. We don't need to do any NOT configuration because this has real IP addresses. However, this is zone 0 and this is zone 50, which means no traffic originated from the outside can go to this server. And I want to open up HTTP as well as HTTPS towards this server. So then we have to define our access list so it doesn't use anything specific to a specific interface. Let's do access list, and we will call it ACL server 1. And we want to permit TCP from anywhere towards, okay, we need an object to make this better. Object network server 1. We'll do host 193.234.88.3. Okay, let's do this again. So access list ACL server 1 extended permit TCP any to server 1 equal 80. We need the object keyword before. 80 and 443. That's HTTP and HTTPS. So there we go. And we can't just put this on the outside interface. We need to set it on the global instead. So we'll do access list ACL server 1 in no sorry, not access list, access group ACL server 1, and it's global, just like that. So this is what it looks like. And because we enabled it globally, every packet will be affected, but the only packets that do have this IP address range as the destination will be the return packets or the initiated packets coming from these two directions. Okay. Let's see if we can try this. Oh, sorry, I forgot one thing. We haven't set up the routing yet. We only have the directly connected interfaces this far, but we want these two interfaces to be our default gateway. So we need to define static default routes. We could do an equal cost load balancing. So we set this IP address as gateway in one route and this as gateway in another with the same metric. And then it will send first this, then this in a round robin kind of fashion. And that'll work. But in our case, I want to do, so ISP1 is our primary and ISP2 is our secondary. So if this fails, all traffic will go this way. And if it works, all traffic will go that way. So we'll just do route ISP1, and we'll do static default route towards ISP1, that's 16.16.6, and then we can specify the metric. The lower number, the higher priority. So we'll set metric 1 for this route. And then in the other direction, this is IP number .2. We'll set a 2. So if we do sh run route, we see how it's configured. Oh, sorry. Let's do this again. So the second route should go on the ISP2 interface. This is why it's always good, after you have configured just anything, do the sh run command. It's very simple on an ASA. Okay, so if I do sh route, we should probably only see the primary. That's right. And if this fails, at least a link failure, all traffic will go this way. And if it's some kind of access problem, so the link is up but we can't communicate that way, we could set an SLA tracking object. So the firewall will ping the gateways like every 5 seconds or so, and if they don't get a reply, it will declare that it's down, and then it will send traffic this way. But we're not doing this, and we're not doing that in this lab. Okay, so now the routing is up. We need something to simulate internet, and I will create a loopback address on both of these routers, the same IP address. So it's kind of like an Anycast address. So if we ping that one, it can go to either of these routers. Let's see, enable, and we'll create a loopback 0. IP address, let's call it 5555. and it has a 32-bit mask. No shot. And we'll do the same on this one. Let's see if we can ping that one. It should be ISP1 that responds. Yes, we can. And let's see if we can ping it from this server. No, we need to inspect ICMP as well. Let's just do this. We'll create let's see. We'll create a very simple global service policy for just ICMP. So we'll do class map everything, match any, and we'll do a policy map, and we'll call this global class everything inspect ICMP. And we'll do service policy global. Okay, so now we are inspecting ICMP, which means that the firewall will allow the return packets of ICMP. Are we able to ping our default gateway? And we are sending the packets that way. And from this one we can ping 555. And we are inspecting ICMP. Perhaps it's our not rule. How does it seem? We go from inside to any dynamic. It shouldn't hit, I think. Maybe we need to create an identity not for server 1. Let's try that. Sometimes when you have NOT on one interface and you don't want to use NOT on another, it doesn't seem to work so well. So then you might create a NOT exception instead. That's identity NOT. For more information about identity NOT, please watch the episode about NOT. I will just do it real quick here. Okay, so we need a network for that one. Let's see. Access. Object network. DMC network. And that'll be the subnet of 193.234.88.0 with a 29-bit mask. And then we'll do a NOT statement. So NOT inside. No, not inside. DMC any. Like this. And it's static source the real source is the DMC network, and we're going to translate that to the DMC network. So no change. I think that ought to be enough. So from DMC to any source static, the DMC network, translate it to DMC network. So don't touch it, basically. It doesn't hit it. DMC. Let's do this. Logging buffered 7. No logging console and logging enabled. And this is pinging. Let's see what it says. So deny ICMP from the DMZ to ISP1 by access group ACL server. Okay, that's right. ACL server. Maybe we did our ACL a little bit too broad. Because we put this on all interfaces, which means we check for it even here. So permit TCP any. We need to permit all our own networks. So access list ACL server 1 extended permit IP from 192.168.192 network to any. Extended. Oh, there's 2 C in access list. 192. Didn't we define? We need the object. Sometimes you need the object and sometimes you don't. So it's quite difficult to remember sometimes. DMC network. Okay, let's see this. I removed the NOT as well. Okay, now it works without the identity NOT. Okay, so server 1 has connectivity and it's through the ISP1. So the packet goes from here to here, out on this, and in this case it just goes back because we don't have any internet set up. But if it were to go to the internet and it were to respond in this direction, then it would let the packet through. And let's see if the NOT works on this one. Yeah, that works as well. Okay, now you know how traffic zone work. Thanks for watching and thanks for today.